Hi everyone, let's continue with session 10.1. So last time we talked about the relationship between xy relation and the parametric equation. So given the parametric equation, how do you find the xy relation and figure out the curve? Or given a function or xy relation, how do you find the one of the parametric equation associated to it? Okay, so today we're going to talk about the main applications on the parametric equations. They are the derivatives, area, and arc length. So before we talk about the formula of the parametric equations, let's talk about the formula of those for our regular functions. So what is derivative? Well, we know derivative represent, so if we have a curve, derivative represent the slope of the tangent line at that point A, right? And what is the derivative formula? Well, f prime of x is dy dx. So that's the derivative formula. How about area? Well, area, we're talking about the area under a curve. Okay, if this is f, what's the area under the curve from A to B? Well, the area equals to the integral of, well, how do we do it? You cut it into like small rectangles and then you sum them up. That's why you get integral from A to B, f of x dx. And actually, what is f of x? Well, f of x is actually y. Y is the function of x, right? And you can think about it's like the sum of those area of rectangles. The rectangles, each of them, the width, okay, the width, this is like y, and this guy is like change of x. That's each of the rectangle. Okay, that's the area. How about arc length? What's arc length? Well, you kind of cut the curve into small pieces and then you sum them up. So this is like change of x, this is change of x, this is change of y. Okay, and change of x equals to square root of change of x squared plus change of y squared. And that's why arc length, L, is integral from A to B square root of 1 plus dy dx squared dx. This is our arc length formula. Do you remember? Okay, so today we're going to visit for parametric equation. We're going to figure out what is the corresponding formula for derivative, area, and arc length. Okay, so in this chapter, 10.1 and 10.3 are so important. So in 10.3, we're going to visit polar coordinates and polar curves. So we're going to figure out the formulas for polar functions. Okay? Alright, so first of all, let's look at derivatives. Derivative for parametric curve. Okay, so let x and y be function of t, and they are differentiable. So here I should say where x and y. So we consider them a function of t. So they are differentiable on the interval AB. Then dy dx is, oh, it's like chain rule. It's dy dt over dx dt. Okay, so that is y prime of t over x prime of t, provided the denominator x prime of t is not 0. Okay, it's like you both the numerator and denominator divided by dt, but it is actually chain rule. Okay, so what is our formula? Our formula, let's use a different color pen. Which color do you like? You like pink? Yes. Alright, so the derivative is then dy dt over dx dt. You can see here we have dy on top and dx on the bottom, so this is like that. So y prime of t over x prime of t. Okay, so that is the derivative formula. Now let's see how do we solve example part A. So example 8. A curve C is defined by the parametric equation x equals to t squared, y equals to t cubed minus 3t. Part 8. Show that C has two tangents at the point 3, 0 and find their equations. Part B, find the point on C where the tangent is horizontal or vertical. Part C, determine where the curve is concave upward or downward. Part D, sketch the curve. Okay, so first of all, let's verify whether the point 3, 0 is on the curve. Well, 3, 0 is like x is 3, and the y is 0. So x is 3 is like t squared equals to 3, then what is t? Well, t equals to plus or minus 3, right? In that case, the y is then, when we plug in plus or minus 3, square root of 3, that square root of 3 cube, okay, that will give us negative 3 square root of 3. Oh, this guy will cancel, right? We get 0. And also when you plug in, okay, so y of square root of 3, and this is y of negative square root of 3. Then we get negative square root of 3 cube. Okay, the negative 1 cube is negative 1, so that's why we can put the negative outside. And then minus negative become positive. So we also get 0. So the point 3, 0 is on the curve, and there's 2 t values associated to it. T equals to plus or minus root 3. Okay, so let's find the tangent line. Okay, so find the tangent lines at t equals plus or minus root 3. So tangent line, we need the slope of tangent. Slope of tangent is dy dx. Evaluate at t equals to those values, right? Square root of 3 and negative square root of 3. Okay, so let's see. What is the derivative? Well, the derivative is y prime of t over x prime of t. Well, y prime of t is derivative of t cube is 3t squared. Derivative of 3t is 3. X prime, derivative of t squared is 2t. Okay, so let's see. When t equals to square root of 3, m tangent equals to, we plug in square root of 3. So 3 square root of 3 squared minus 3 over 2 times square root of 3. Square root of 3 squared is 3. 3 times 3 is 9. 9 minus 3 is 6. But 6 and 2 cancel, we get 3. Of 3 over square root of 3, because 3 is square root of 3 times square root of 3, so the answer is square root of 3. Okay, now we know the slope, we know the points, it passed through the point 3, 0, then we can use the point slope form. Y minus the y coordinates of the point, which is 0, equals to the slope times x minus the x coordinates of the point, which is 3. So we get y equals square root of 3 minus x minus 3 square root of 3. Okay, so this is one of the tangent line. And when t equals to negative square root of 3, what happened? Well, m tangent is 3 negative square root of 3 squared minus 3 over 2 times negative square root of 3. And negative square root of 3 squared is also 3. So the numerator we still get 6, but the denominator we have negative 2 square root of 3. Well, that is just the same as before, except we have a minus sign. Okay, and so our point slope form, the slope, the point is still 3, 0, but the slope now is negative square root of 3. So that's why we get y equals negative square root of 3x plus 3 square root of 3. Okay, so they are tangent lines. What's the picture looks like? Well, at the point 3, 0. Okay, we have two tangent line. This tangent line is square root of 3x minus 3 square root of 3. And this tangent line is negative square root of 3x plus 3 square root of 3. So we actually have two tangent lines passing through the same point. So far, so good, everybody? So that's part A. Let's look at part B. Find a point on C where the tangent is horizontal or vertical. Okay, what does that mean by saying the tangent is horizontal? Well, that corresponds to the numerator of dy dx is 0, right? So our slope is 0. Okay, what happens if the tangent is vertical? Okay, so here m is 0. It means the denominator, if the derivative is like a fraction, okay, the denominator is 0. Okay, that means our slope is undefined. So let's see. Our derivative is this guy. Okay, so horizontal, that will give us 3t squared minus 3 equals to 0. Solve for t. Well, then we get t squared equals to 1. Because we move the 3 to the other side, become 3. Then we divide it by 3, we get t squared equals to 1. So, t equals to plus or minus 1. Okay, if t equals plus or minus 1, what is the x and y? Wow, okay, so t equals to 1. That corresponds to x equals to, let's see, x is t squared. So 1 squared is 1. Okay. But the y is 1 minus 3, which is negative 2. When t equals minus 1, that corresponds to x is t squared is also 1, but y is, because we plug in minus 1 cubed is minus 1, plus 3 is then negative 1 plus 3 is then 2. So it corresponds to 2 points. 1, negative 2, and this is 1, 2. Okay, so we have 2 points that we have horizontal tangent. And when do we have a vertical tangent? Let me use a different color. Okay, so vertical tangent is when the denominator is 0. Okay, denominator is 0. What happened? Well, denominator is 0, so that gives us t is 0. So when t is 0, what happened? We get x is 0 and y is also 0 minus 0, 0. Oh, so we're actually at the point 0, 0. Okay, what does that mean? Let's draw on the same picture. So at 0, 0, here we get a vertical tangent. At the point 1, negative 2, like here, we have a horizontal tangent. At 1, 2, we also have a horizontal tangent. Okay, so you can see this is the picture looks like. Okay, let's continue. Part C. Determine where the curve is concave upward or downward. Okay, let's see. Let me copy the problems here again, so then I don't need to flip back and forth. Okay, so we already did part A and B. Okay, so, and don't forget that our derivative, this is our derivative. Let me see, how can I copy it? Okay. 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 Oops. It forget to copy this guy. Let me copy this guy as well. All right. Okay, so it's still the same problem. Okay, where is the curve concave upward or downward? Remember from calculus 1, concave up or down is about the second derivative. So it's related to the second derivative with respect to x. So how do we find the second derivative? Well, the second derivative with respect to x, not with respect to t, be careful. Well, that is the same as the derivative of the first derivative. Well, that's the same as the derivative of the first derivative with respect to t over dx dt, right? It's like you squeeze the dt and dt downstairs, both in the numerator and denominator. Okay, and what is that? Well, the top, we're gonna differentiate this guy, but I really don't like quotient rule. So let me simplify it. Okay, so I simplify it, I split. So I get 3 over 2, t squared over t is t, minus 3 over 2, and then we have t at the bottom. So far, so good, everybody? And let's differentiate that. 3 over 2t derivative is 3 over 2. 3 over 2, this is like t to the minus 1, so it's negative t to the negative 2, which is t squared in the bottom. Okay, because t to the negative 1 derivative is negative t to the negative 2. Okay, and dx dt, x is t squared, so this is 2t. Oh, so what is that? Is 3 over 4t plus 3 over 4t cubed. So far, so good, everybody? And let's simplify it, okay? Let's simplify it. The common denominator is 4t cubed, and can factor out the 3, then we have t squared plus 1. So far, so good, everybody? Oh, okay, so when is the curve concave up or down? Remember the second derivative, if it's positive, then f is concave up. If the second derivative is negative, then the f is concave down, right? So that's why here, this guy, t squared plus 1, is always positive. Then the only thing make it positive and negative is the denominator. So when so you can see when t is positive, then our second derivative is positive. So function is concave up. And when t is negative, then you can see the second derivative is negative, so function is concave down. Okay, so with that information, let's sketch the curve. So D, how do we sketch the curve? Okay, so we take all the information from part A to part C together. Okay, so we pass through 3, 0, and the points from part B, we know it passed through 0, 0, and it passed through 1, negative 2. So this is 1, this is negative 2, and it also passed through 1 and 2. Okay, at 3, 0, we have 2. Let me use different color. So we have 2 tangent line. Okay, this one, the slope is square root of 3, and this guy, the slope is negative square root of 3. Okay, and here the slope is 0. Here the slope is vertical. Okay, so if we connect them smoothly, what do we get? So if we connect them smoothly, we'll get this guy is like This is what the picture looks like. Can you imagine? And you can see on top, you can see it's concave down. So when t is positive, so let's see here. Remember your t, your y is t cubed minus 3t. Okay? And when t is, so this is the same as t squared minus 3. Okay? When t is positive, then you can see between when t is positive, but when t is less than square root of 3, okay, this guy is actually negative. Okay, so this is when t is between 0 and square root of 3. Okay, so then it's negative. So that corresponds to this piece. Okay, let me see. Let's see here. Oh, so when t is positive, this guy is actually corresponding to this piece. So that's why when t is, so this is when t is positive, it corresponds to this piece, so we have concave up. Okay, and on the other hand, on the top piece, it actually corresponds to, so when t is negative, then y is like t squared minus 3. So this guy is negative, and so when t is between negative 3 and to 0, then we can see this guy is actually positive. Okay, because this is negative, make it positive. So it corresponds to this piece. So that's why we have concave down. Okay, so actually our result from part A to part D match with the graph. So far so good, everybody? Yeah, so this guy corresponds to t is plus or minus square root of 3, and this guy corresponds to t equals to let me see. So 1, 2 correspond to t equals to minus 1. This guy is t equals to 1, and this guy is t equal to 0. So t equals to minus 1 is actually correspond to this point. So this piece is t is negative, so concave down. Okay, and the bottom t equals to 1 is t is positive, so we have concave up. Okay, so that is problem 8. Okay, next, area. So the area under a curve, okay, the regular formula was integral a to b f of x dx, okay? But now it's the same as y, okay? It's the same as y dx. But now think about x and y, they're a function of t. So y, we can have y of t, but dx, what's dx? Well, dx is dx dt times dt, right? Because the dt sort of like cancel out. So this is, the dx becomes dx dt times dt. Then this is our formula. So our formula is integral, so alpha and beta are the t values, a and b are the x values. Okay, so change the bounds, the limits of integration to t values. And then we have y of t, x prime of t dt. Okay, so let's go back to our formula table. And okay, so our area is then alpha beta y of t, dx is dx dt times dt. Well, that is y of t, x prime of t dt. Okay, so keep this in mind. Let's continue and look at example 9. Find the area under one of the cycloid. So we have x and y. Okay, so here, what do we need? We need x prime of t. So what's x prime of t? Well, r stay here. Derivative of t is 1. Derivative of sine is cosine t. Okay, so we have integral. So this is area. T goes from 0 to 2 pi. And then y is r, 1 minus cosine t. This is the y. But x prime is, the same thing. Alright, so this is y of t. This is x prime of t. But actually, they're the same. Okay, r squared, so r and r give us r squared. We can pull it out. And then we have 1 minus cosine t squared. Well, how do we integrate that? We should multiply it out. So it's 1 minus 2 cosine t plus cosine t squared. Okay, are you able to integrate 1? Yes. Are you able to integrate 2 cosine t? Yes. Are you able to integrate cosine squared? Wow, we need something. Do you remember what is that something? If you have even power, what do? How do you decrease the degree? Remember, we decrease the degree, we will actually double the angle. So that is the double angle formula. Okay, so in general, if you have sine, what happens if you have sine? So if you have sine, you will have 1/2 minus. Okay, so let me just put it down in case in the next problem, if you see sine, then you still know how to do it. So sine squared is 1/2 minus 1/2 cosine 2t. Okay, let's continue. So we have r squared 1 minus 2 cosine t plus 1/2 plus 1/2 cosine 2t. So this 1/2, add this one, they give us 3 over, 3 over 2, right? 3 over 2. So let's integrate it. So 3 over 2, integrate with respect to t is 3 over 2t, and then we have minus. Integral of cosine is sine, right? Because the derivative of sine is cosine. And integral of cosine is sine. But because of 2t, we need to divide it by 2. From 0 to 2 pi. Alright. And let's see what happened. So we plug in 2 pi first. So we have 3 over 2 times 2 pi. Sine 2 pi is 0. Sine 4 pi is 0. You know, sine is like this. Okay, so 2 pi, 4 pi, they're all zeros. Okay, so when we subtract 0, when we plug in 0, everything's just gonna be 0. So 2 cancel. Our answer is 3 pi r squared. So far, so good, everybody. So this is the area. So this orange area. Okay. So just use the formula and then find the x prime. Okay. All right. Let's continue with arc length. Okay, so arc length, remember we have 1 plus dy dx squared, but you can think of dy dx as like dy dt over dx dt. And then what happened? You can split. So you can split this as like a dx dt squared over dy dt squared over dx dt squared. And what's dx? Dx is dx dt times dt. So now you move the dx dt inside the square root. Then you get 1 plus dy dt squared over dx dt squared times dx dt squared dt. So now when you distribute it, This guy times 1 is dx dt squared. This guy times the second term, they cancel, right? So that's why you have this formula. Okay, dx dt squared plus dy dt squared. Okay, let's copy it down on our table. So now our table is complete. Okay, so this is alpha to beta square root of dx dt squared plus dy dt squared dt. Okay, so now let's see how do we solve those examples. Okay, find this odd length under 1/2 of the cycloid. Okay, so what's x prime? Well, r stay here. Derivative of t is 1. Derivative of sine is cosine. Y prime is derivative of 1 is 0. Derivative of cosine is negative sine, so negative negative become positive. Okay, everybody? So now let's see. At length is integral from 0 to 2 pi. X prime squared, so r squared 1 minus cosine t squared plus y prime of t squared, so r squared sine t squared dt. Can you see the common factor r squared? So let's multiply out and let's factor out the r squared. Okay, when we multiply out, we get 1 minus 2 cosine t plus cosine t squared. And once we factor out the r squared, we just get sine squared. And do you know what's sine squared plus cosine squared? Wow, that is 1. And do you know what square root of r squared? Because r is a number that's positive, so square root of r squared is just r. So we can put the r outside of the integral. And then we have 1 plus 1 will give us 2. So we have 2 minus 2 cosine t dt. Okay, how can we calculate square root of 2 minus 2 cosine t? Okay, so you gotta be very familiar with the double angle formula. Okay, yeah, that's why I said for calculus 2, double angle formula is so important in our course. So remember the double angle formula is like 1/2 minus 1/2 cosine 2 theta is sine theta squared, right? 1/2 plus 1/2 cosine 2 theta is cosine theta squared. You want to get something square here, so you want to express this guy as something square so that you can cancel with the square root. Wow, which formula do you use? It looks like this guy, isn't it? But you have 2 instead of 1/2. Then you multiply both sides by 4. Then you can get 2 minus 2 cosine 2 theta equals to 4 sine theta squared. Now plug in theta equals to t over 2, right? That will work. So we get 2 minus 2 cosine 2 times t over 2 is t equals to 4 sine t over 2 squared. Yes, so we get this guy equals r 0 to 2 pi square root of 4 sine squared t over 2. Well, square root of 4 is 2, so we can put the 2 in front as well. Square root of sine squared, it actually becomes absolute value. Okay, everybody? So now what happened? Well, we're gonna see, okay, so we need to restrict the angle, okay? So because it's absolute value, let's draw the picture of sine. So we know the picture for sine is like this, right? And this is 0, this is pi, this is 2 pi. Okay, and how about t over 2? So when t equals to 2 pi over 2 is actually pi. So the angle is now between 0 to pi. You can see that the entire function is positive. So that's why the square roots, the absolute value of sine t over 2 is just sine t over 2. So we can realize because sine t over 2 is positive over 0 to 2 pi. Okay. Let me get more space here. We have 2r. Integral of sine is, think about the derivative of cosine is negative sine. So we have negative cosine. And then we divide it by 1/2. That's the same as multiply by 2. Okay, evaluate from 0 to 2 pi. Okay, so now we plug in, 2 pi, right? So when we plug in 2 pi, what do we get? So we have 4r. So 2r, 2. So 4r. Okay, we plug in negative. So cosine of 2 pi over 2 is cosine pi. So cosine of pi is -1. So negative 1. And then we subtract negative. Negative become positive. When we subtract 0, cosine 0 is 1. So we actually get 2 times 4r, which is 8r. Okay, so that is our answer for example 10. You can see we first figure out x prime and y prime, and then we plug into the outline formula, and then we realize square roots. You remember, in order to solve the integral involving square roots, we kind of hope that there is something complete square there, so then we can cancel the square roots and then we can continue. So here, make sure you're familiar with the double angle formula. Okay, so let's continue to our last example of this session, example 11. So first of all, we need to figure out x prime and y prime. So x prime is chain rule 3a cosine squared. U prime, u is like cosine. So derivative of cosine is minus sine. And then y prime is a 3a sine squared. Derivative of sine is cosine. Okay, then L is the integral. So we want to find the outlength under one out of the asteroids. So here you can see all over the 2 pi, because it's symmetric, it's okay that we just compute one of them, and then we can multiply 4 copies of that. Okay, so let's just calculate the pieces on the first quadrant. What's the good thing about doing that? Well, because in the first quadrant, your sine and cosine is always going to be positive. So when you take square roots, you don't need to worry about, oh, whether it's positive, then the absolute value is that guy. When it's negative, then the absolute value is negative that. So you don't need to worry about this issue. Okay, so it's always good that if you realize it's symmetric, then you restrict to some angle and multiply by how many copies of that. Okay, x prime squared. So we have 3 squared, which is 9, and a squared. And then we have cosine to the 4th sine squared. Y prime squared, 9, a squared, sine to the 4th, and cosine square. Can you see there is some common factor here? What is the common factor? Well, that is 9a squared cosine squared and the sine squared. And what's left? Here we have cosine squared. Here we have the sine squared left. Oh, what happened? This guy is 1. Oh, so we have the square roots of 9 is 3, square root of a squared because a is positive, that's a, and then you have absolute value of cosine and sine. And because we restrict our angle to 0 and pi over 2, sine and cosine are all positive over that angles. So we have moved the 3a outside, we get 12a, and then we have integral 0 to pi over 2. Cosine t sine t. We can just get rid of the absolute value because sine and cosine are both positive over here. Okay, so here what do? So there are 3 ways you can continue. Okay, so the first way, you can use u substitution and you let u be cosine t, then your du is minus sine t dt. The second way, use u substitution, but you let u be sine t, and then du is cosine t dt. The third way, which is the easiest, recognize that 2 cosine t sine t is sine of 2t. So this one is the easiest. Okay, so what I do is I want to borrow a 2 from here. So 12 is like 6 and 2 here. So now this guy is sine of 2t. So my answer is 6a integral 0 to pi over 2 of sine 2t dt. That is integral sine is, so you think about derivative of cosine is minus sine. So integral of sine is negative cosine. 2t, but you also need to divide it by 2. Evaluate from 0 to pi over 2. So this 2 cancel, we have 3. So negative 3a, we plug in cosine 2 times pi over 2 minus negative become plus 3a of cosine 0. Okay. Cosine of pi is minus 1. Oh, I get 3a plus 3/8, which is 6a. So my answer is 6a. Okay, so that is the outline of this asteroid. So far so good. So here you can try the u substitution. So we have 3 ways to solve this integral. Okay, but when you see square roots, when you see square roots and there are so many functions with the square roots we're not able to solve. Okay, but for the ones that we're able to solve, you can always make a complete square inside the square roots, so then you can get rid of the square roots, cancel that out. And also don't forget, if the graph is symmetric, then you can restrict it into the first quadrant, and then in that case, your sine and cosine are both positive. Then when you get rid of the absolute value, it's much easier. Okay, so that is session 10.1. Bye.